Hello everybody and welcome. My name is Gayanko and I'm a second year computer science student at the College of Management of Academic Studies in Rishon LeZion, Israel. I'm about to introduce you our project in Advanced Software Development course I was working on in collaboration with my friend Eyal Roman. The course lecturer is Dr. Eliyahu Halaschi. Eli, thank you for your guidance along the way. The project includes 5 major milestones. The first milestone focused on the design of the server-side architecture in accordance with solid and GRASP principles. In the second milestone, we've made the implementation of the server and the cache manager using files and socket streaming. Next milestone, we've implemented an algorithm used by the server to solve a generic problem from a connected client. After we finished the server side, we started our work on the client side as a desktop application. Milestone number 4 was about building a custom language interpreter. The interpreter is able to run a script with various commands and use those commands to control an aircraft based on Flight Gear Simulator. Finally, in milestone number 5, we've merged all our work into a graphical user interface using MVVM architecture. Later on, I will explain more about the project and about the design patterns we used. But now, let's see a demonstration. Let's run the server. Let's run the client and Flight Gear. Okay, great. So the application is running. Now, we will load the map from a high-based CSV file. You can notice the color differences that represent the CSV file as a topographic map. Now, let's wait until we will get the aircraft position. Okay, great. So we got the aircraft position. Now we can choose a destination and calculate the best path. To calculate the best path for the first time, we need to connect the server. You can see that the server is listening on port 5033. Okay, so you can see that we got the lowest height path to our destination. Now let's choose another destination. Great, so we got the lowest height path. And now let's get ready to a short flight. Let's connect to simulator. Let's switch to autopilot mode to load the script. Now we're going to run a script that will help us to take off the aircraft. Let's start the engine. Okay, so everything is ready. Now we'll hit run script. And you can see the aircraft starts moving on a straight line on the runway. You can also notice that the aircraft is moving on the map. And after taking off, when we will reach 250 feet above the ground, I will switch to manual mode and we will fly manual the aircraft. And now we are rotating and we are taking off. You can see that the aircraft is moving on the map. So we reach a safe altitude. And now let's move to manual mode. Here I can move the throttle and the rudder, and we can control the aircraft from the joystick. Okay, let's close the simulator and the application. Okay, so now we will discuss about the project architecture. Let's take a look on the UML diagram of the server side. Here we can see the segregation between the server that in charge on listening to a socket and the client handler that define the communication protocol. That segregation helps us to get a single responsibility of each interface. Also, to be able to solve a different kind of problems, we used an object adapters. Here we can notice the one called Solver Searcher. Moreover, to be able to solve different search problems with different algorithms, we use the bridge design patterns. Now, we can run search on any kind of searchable with any kind of searcher. Now, let's discuss about the client side. As I told you before, we use the MVVM architecture for the client side. For the view controller, you can see that there is four data members: the joystick, the map, aircraft, and path that extends canvas, and the FXML connection. Here you can see three major classes: the view controller, the view model, and the model. As you can notice, the relation between these three major classes uses observer pattern and data binding. The view observes the view model, and the view model observes the model. The similar variables in the view and in the view model use data binding to be updated as values changes all the time. Also, the view model is responsible to adjust the input from the user interface so the model will understand it, and vice versa. To be more clear about the data binding, let's watch an example. This is our joystick and our aircraft on the flight gear simulator. The joystick got its X and Y values on the graphical user interface grid. Those values have binding to the view model elevator and aileron values. When I move the joystick, it invokes the move elevator and aileron function at the view model. The view model adjusts these values and invokes the similar function at the model to send the new values to the simulator. That mechanism helps us to move the aircraft controls via the user interface joystick. Okay, that's it. I was Guy Yanko, working on the project with Eyal Roman. Thank you very much for watching, and you can find more about our project on my Git. Bye bye.